I'm really happy to present a little library I did in Scala, where I use macros to transform DSL to Datomic called queries. And Datomic is a super cool database that I'm going to present a little bit about. And yeah, I'm going to talk a little bit about the Datomic database itself, and then how I have built a DSL, like a domain-specific language, with Scala macros to adopt to this database. And then I'm going to talk a little about different features I have in the molecule library that I've made. And then just briefly touch on some ideas of how you can use molecule in your domain modeling. So let's go. Datomic has facts and some entities, and it's an immutable database, which might sound strange to have a database which can be changed, but it's basically collecting facts, so it collects more and more data without ever erasing anything, which gives some very cool time features that I'm going to show a little bit, and then I'm just briefly going to show how the architecture basically is. If you look at the most basic data model you can have, there will be a key and a value, but it doesn't really tell us that much. It tells us about a number and some string, so we don't know where it comes from and what the purpose is or anything. So if we expand it a little bit, we could talk about the fact that, for instance, Fred likes pizza. Then we have an entity and some attribute with some value. So entity is Fred. It could be a house, a company, or whatever. And there's some attribute or property of that entity. And then that property has a value. But there's also the time aspect, because if you just think like Fred likes pizza, you don't know when he stated that. So you need time also to tell what is this fact related. When was this stated? So if you want to erase a fact like I don't like pizza anymore, Fred doesn't like pizza anymore, you even need like an operation which says Fred doesn't like pizza. So you retract the fact. So, and you can say that happened at time 11:16. So now you have basically a quintuplet instead of a key value, and that gives you quite a lot of information. And it turns out that this is the information that Datomic uses. So this is the core data model of Datomic. Those 5 things are what you need to create a complete data model, actually. So if you have entity, attribute, value, and transaction, I wrote a time mark before, and in Datomic they call it a datum. So it's like a play on the word atom, and also Datomic, of course. And they have the 2 operations, assert and retract. So you can either assert a fact that this happened, or this is a fact now, or you can retract it, now it's not a fact anymore. So it's often like concatenated, so they just write E, A, V, T, and operation. So E for entity, A for attribute, value, transaction, operation. So in order to distinguish the different attributes, then Datomic uses what they call namespaces, which is just a little prefix to the likes. So you have what is it that like, when it's a person that likes something. You could also have other things that likes things. So it's just a convenient way of identifying what it is that likes. So in Datomic, you build up a schema of which is like definitions of what attributes can you have in the system. So it's basically you save the schema as attributes themselves. So it's like bootstrapping an application with its own code, kind of. So you tell it that you have an attribute which is like a core attribute of the Datomic system, which is like database identity. Is like you have an attribute which is identified as a person shares likes. So you have also a type that is a string, or it could be a boolean, a long, big, float. So the usual suspects, but also a reference, which is how you make relationships to other entities. I'll show you how that works. And then instant, which is a date. Yeah, and a few more. And you have cardinality, which is also a cool feature of Datomic, that you can have cardinality one or many attributes, which normally you have only cardinality one attributes in most database systems. And then you have to create some mechanisms to get multiple values. Whereas here it's at the core of Datomic that any attribute can have either multiple values or a single value. So cardinality many values have set semantics. So it means that if you have multiple values, they're all unique. So you can have like 10 of the same value in one cardinality many attribute. Then you can have add some options that you can, for instance, describe with a little documentary of like what a person likes. So you describe it with human words what this attribute is about. Because you can query the schema and get knowledge about how does this database, how is that constructed, how is my schema. So I can ask what is the doc value? Well, it's what a person likes. So that gives me human information about what did I think about when I defined this attribute. And then you have some further options, which are that you can ask the database to enforce that it's a unique value, for instance, or that it should be indexed, or it should have a Lucene full text index searching system, so you can search in big text. And there's this component, which is a cool option which tells that if you have a reference to cardinality many reference to other entities, like if you have an order with line items, if you define the order attribute as cardinality with its component, then that order owns the line item. So if you delete the order or retract the order, then you also automatically retract all the sub-components, which is a really cool feature.
Can I ask a
question?
Yeah. Is it possible to have your own attributes on the schema, so you can add like your own metadata about the attributes?
I think so, yeah. But I think you can do that actually. I mean, you can't make predefined. There's some reserved attribute namespaces like :db. Of course, you can change that. But I think you can. I think I recall that you can add metadata about your attributes. I don't know exactly how, but I think it's possible. So if you look at an entity, what an entity is, then it's basically a group of facts which has something in common, and that's the entity value, which is I just put in a random number, 110, 101. So you have like 4 facts. So the first fact is a person name, which is Fred. So the value is Fred, the attribute is person name, and the entity ID is 101. So the next fact also has entity number 101. So they all share this, which makes them an entity because they're tied together by the entity ID. So that means also that you can also tie together an outsider, like an attribute which doesn't look like. I mean, the first ones looks that is everything is from a person related, but you could add whatever attribute to that entity, which is just saying that it has the same entity ID. So, for instance, we could want to say in a shopping system that this person is a customer. So we could take an attribute from the site namespace, which has a category, and say that, and then apply that. So we state a fact with the same entity ID. That becomes one entity then. So that information gets connected with that person. So we could represent it like this also. So you would have like, because the entity ID is the same for all the 5 facts. So we can present it like this. So we have the attribute names and the values on the right. So it's basically just a group of facts with a shared entity ID. Then you have relationships, which where you have an entity value on the here, which is a reference. So you define this attribute as a reference. So when you define it as a reference, it means that the value is pointing to another entity. So here you have an entity 102, which has some series of facts. So that's how you make a relationship. So, yeah.
Can you restrict the type of those entities, or are all entities alike?
All entities are alike because it's basically just an entity ID is a long number. Okay. So there's nothing else.
Because that's where one place where you could have, for this attribute, I want to restrict it to certain types.
Yeah.
And then you could have your own type attribute, but there could be some metadata about the relationship that this relationship can only point to an entity of a certain type, for example.
But references or relationship always point to an entity. So it's pointing to the entity number, which then collects a group of facts.
Yes.
Yeah, and there you could have any data.
Yes.
So, and there you could also have any metadata as you want it. Yeah.
So does that entity need to exist?
If what?
Does that entity that you're pointing to, does that need to exist?
No. No, you can define the reference attribute. So it's only when you state a fact that now there is you reference this number. So that number has to exist. You can't just put in a number. So Datomic has a special way of saving those. So it has to be an existing.
Create the entity somehow first.
Yeah, yeah. But I don't know if you retract all the facts of an entity. Actually, you can't remember what happens then, because then you have an empty entity, which is basically what you asked about. I don't know exactly how that goes. But here is an example of having a cardinality many reference, which could have 2 values, like for instance 103 and 104, which points to 2 different entities. So if we compare, like in normal systems, like SQL systems, which have tables, they're mutable. And we'll see how that compares to the immutable facts of Datomic. Because here, if you see at the 3 bits of information we have here that Fred likes pizza, in the table we have the same information here. So we have an entity which is like Fred, he likes pizza, and the likes column is the same as, basically the same as the attribute name. And you might have a person document which says like there's an entity, an ID of Fred, which might be a number, and he likes pizza. So what happens then? if we want to know when it happened that Fred liked pizza, then we would have to create a new column traditionally in SQL, SQL database, or it would have some auto creation date or auto modification date or something, but at least it would be a separate column. And also you would need to create a new field in the document telling at what time it happened. Whereas in Datomic you have the transaction which are transacted in orders, and there's time information coupled to the transaction, so you can always tell when it happened. Save data. In a traditional database, you would override that value, and then you would put in like updated time, maybe, so you knew when it was updated. But you wouldn't have you wouldn't know what the value was before, right? You would have to create a separate log or something to know if what the value was before. Otherwise, you just override it. So the information of the past is just gone. If you have a person that changed addresses 10 times, you don't have a clue about what was the addresses before. And it's actually the same in a document. As far as I don't know so much about documents, but I think it's the same, isn't it? That you override, you create a new document with a new value, so you don't know the old value. So in Datomic, it's two things happen. When you assert a new value for the same attribute and the same entity, two things happen. The old value is retracted, and the new value is reasserted. So that gives you information that we had at 10:31, it was asserted that Fred liked pizza. But then at 12:45, Fred likes pizza, not, right? And then Fred likes pasta, yes. So that gives you the time perspective to when things happen. And the same, well, with deletes, you have the same problem with traditional databases, because you would maybe put in a null value that there's no value now. He doesn't like anything, or it's not non-existent. But so that tells you absolutely nothing about what it was before, right? And it's the same here. I don't know how you do it in documents. Maybe you don't even have the field. I don't know. But what?
I guess the entity ID stays the same.
Yeah. Yeah. So you can see we have 3 transactions which are saved in Datomic. So you have a sequence of datums after each other. So you get a huge list of datums. And that's the only thing that there is in a Datomic database. You don't have a lot of tables or things happening all different places. You only have this history, which I think is extremely cool. So when we ask Datomic, what does Fred currently like? Well, then there's no information, because we retracted that he liked pasta, right? So the current value is the last transaction that includes this attribute. So since it was retracted, then there's no value. So when we make the query, find the value of Fred's, what he likes. The value here we get here to find. Then we get 0 result, which is what we suspect.
And this is because the likes attribute is marked with cardinality 1, right?
Well, it doesn't have so much to do with it could be one or many.
But if it was many, he could like pizza and pasta at the same time.
Yeah. Right? Then you could. It's a little bit different semantics when it's kind of many, because then if you assert a new fact which is different from another, some of the other facts for the same attribute, then you have 2 attributes, two values, yes. Right? Yeah, so you could add more values.
But then you can't look at just the last value. You have to go through all of the, or
no, because you always get a set of the existing values. So if you started out with pizza, and then you add, you assert pasta also. Then he likes two things, right?
Mm.
So if you want to take away one of them, then you would have to tell Datomic which one is it that you want to retract.
Yes, but when Datomic has to get the values for this attribute, it has to go through the whole history. Or I guess it does that in some effective way, but
I don't even know exactly how they do with the because it's the value is in itself a set, so it's not that so the set gets accumulated. I think that the new set is I don't know how they do it technically.
okay.
But it's not that you have like you can go through the history of what has been added to the set and what has been retracted from the set. That's what you can go through. But when you get asked for the current value, you get the current values of the set.
Okay.
So I don't know how they do it technically with that.
But there's always only one active item at any time, right?
Yes, you have, yeah.
So and that would be the same in the set.
Yeah, so
it doesn't have to read everything, every history. It doesn't matter. Just checks the current values.
Yeah. So when you do a query like this, it's a query that asks the current value of the system. So it will always be the last stated fact about some entity, right? So it doesn't regard all the other the past ones. But the interesting is, like, if we want to know what he liked at 1 o'clock, we can give it an input database, because the whole system is an immutable database structure of all these facts in the log list, right? So we can give it a database as of a certain transaction time. And that's the super cool feature, because then we get this line where it says that he actually asserted that he likes pasta. So we can come back in time and say, what are the values at a certain time? So when we say as of, that's a function in Datomic, a transaction, and that transaction is basically a number also. I'll come into what a transaction is a little bit later. And you can look at the history also, so you can see what has Fred liked over time. So that takes all four of them. And then you get this, so transaction 4, it was asserted that he liked pizza. Transaction 5, it was asserted that he liked pasta. And retracted that he liked pasta. So that gives you like an audit trail, you could say. And you can also narrow it out, because you might not want to have the whole history, like 2 years back in time. So you could say, like, what has happened since last week.
Can you retract something which is not there?
No, I don't think so.
It will give you an exception or something?
Yeah, I think so, yeah. So you could also say, like, which addresses has person X had the last 5 years? Stuff like that. Then there's also one really cool feature which reminds a little bit of a Git branch, which is a function called with here, which can take some transaction data and apply it to a branch of the whole database. So you can have a production database where you say, like, if I say this customer, how would the data I get out of the database then look? So if I, for instance, had those 4 facts ready to go, and then I could create some test data, say, like, for Fred's entity, he likes pen. What would I get out of the database? Then it would be like as though I had asserted this fact. So when I asked, find the value of a person like this with this test data that I got here, then I would get pen. So, and you can make it much more complex, of course. So you can add a lot of test data without disturbing the database and having to restore it to its original state and all this that we often have to do with when we test. For instance, if you want to test data from a live production database, it's not that easy.
Could you also have retractions in the test?
Yeah.
And could the test data be arbitrarily long, complex?
You could have arbitrarily long.
So it could also include all those recursive deletes or retracts from other referenced stuff.
Yeah.
So you could do a very complex test case and see what would, if I do this, how would everything look?
Yes.
You could also run your tests if you have tests.
Yeah. That is very
cool. Nice.
It's
That's
very nice.
cool.
So you can basically take your production database and start testing right on the data without disturbing the production data at all.
Can you then delete that branch?
No, that branch is garbage collected when the scope is over.
Oh.
It's as simple as that. So you don't have to do anything. So I think that's pretty powerful. So I'll have a look a little bit into how they structured the architecture, because normally many databases have like an all-in-one database server that you have some network connection to. So you ask for data and you write data to a database, separate database server. So what they call a peer, and that's basically a class that gets instantiated inside your application process. And then they have a transactor, which is a separate process that you start separately from your application. And those two, they talk together. So you basically take all the reads to the database and let them happen inside your application, which I think is extremely cool, because then you have like in-memory queries, it's part of your application process. And you separate out all the transactions. So there's a flow when you commit stuff to Datomic, it goes down to the transaction, and that transaction sends transaction to a storage service, which could be a Dynamo database, Cassandra, SQL, or maybe an in-memory database if you're just testing or something. So they're separating different parts of the system to make the different parts more optimized and make them more efficient. Because then the query only needs to handle immutable data. It doesn't have to take care of any transactions or maintaining consistency and everything. That's only the job of the transactor. So the peer sends commits to the transaction to the transaction that updates the storage service, that then updates the cache in your application process that the query uses. Are you with me?
So, if I understand this correctly, the storage service runs on top of some existing.
Yeah, that could be a Dynamo.
So they don't have any. No storage service of their own.
No.
Couldn't it be very inefficient?
No,
varying depending on your backend.
No, it's of course. I think you can, depending on your needs, you can choose. You can just swap the backend as you like. So they have an API from the transactor to all these storages. So you can just swap them out in the configuration file.
Okay. So
I think maybe there are advantages of the Cassandra system compared to Dynamo. I don't know them exactly. I've only used the in-memory as well, and local storage on my disk. The transaction is also taking care of indexing, because you can imagine those quintuplets of data. You have the entity ID, the attributes, and the values. So Datomic keeps 4 indexes all the time, and the transactor is updating those indexes in the background, which makes all the queries really fast. So you can look up what are the values of an attribute. So and then they go in and use the live index that the transactor it keeps updating all the time. So whenever it gets commit, it immediately updates the live index.
Yeah. Question: if the index is very big, and is the index in the storage service or?
The whole well, the index is the database. It is the data just arranged in different orders, right? So it's immutable values, because each quintuple is an immutable value. So you have lists in this order, list in this order, list in this order, and it's the actual data. It's not references to something else.
So I mean, the data could be large to fit in one app process.
Yeah. So the pure caches what is needed for the query, and to the limit it can. So if you have a rather small data set, if you have a website with not like zillions of records, then you might have the whole database in cache, which makes the queries extremely fast because there's no network communication and everything is in memory. Right? But if you have, of course, if you have like 10 billions of facts, then it would probably not fit in cache. And then it goes like, it has like, they have a lot of, they have trees of data that's organized in very broad branches of 10,000. So they, in 3 steps, they can get to any data in the database. So they have extremely fast ways to get to the storage.
And but that's their own implementation. It's not part of like the storage engine.
No. So it's also why it makes it really easy to make an Memcache cluster, because it's all immutable data. You're never going to go back to a list and change a fact. So that makes it extremely fast to cache and easy to cache. So you can just say in your configuration files, I want a Memcache. That's extremely powerful. So there's very little configuration for that. It's part of the Datomic ecosystem.
So is it always better to add Memcache cluster in terms of adding those nodes or adding more nodes as to like a Cassandra cluster?
I don't know. I haven't gone so far. So I haven't come to like production setups. So I must be honest. I don't know exactly. But I know that from the documentation that it's extremely easy to set up. Then whether you need it or not, it's probably, there's a lot of tweaks you can do. But it should be extremely easy to plug and play, kind of. All right, that was a little bit about Datomic, the first part. Do you have some more questions about this? How it's
I have a question.
Yeah.
You said you mentioned these recursive deletes or retracts.
Yeah.
Which are obviously very handy.
Yeah.
Many situations. Is there any auto-create feature? Like if you create an entity or put in a value that it affects other things?
Not that I know.
No. Okay. So it's
there's no auto increment ID or stuff like that. Or no.
Okay. So the automatic. The recursive thing is for deleting stuff, which is orphaned. Would be orphaned.
Would we be what?
Orphaned. There will be having a parent. I mean, if I have a tree of properties, and they have other properties. And obviously, if I delete the parent, I want everything to be erased or retracted.
Yeah, but if you define the reference to the child data as a component, then if you delete the parent, all the components get deleted.
Yes.
And if they have in their turn have components also, it's recursively deleted also.
Yeah, I understand that, and that's what I'm saying. It's very, very handy. But is there anything in the reverse when I create something that it could also create?
No, not that
stuff
no,
recursive.
No,
okay.
No.